Alrighty then. Let's see what we doing now. Looks like we're doing number three. Number three is talking about the argument. Argument just means the angle or theta, right? And so we figure out theta by taking the inverse of tangent of b over a when we think of a complex number like this. So we need to think of a complex number like this in order for us to do that. And so we just take our handy dandy calculator and we're going to push the trig button. This is under and to the slight right of the gray control button. So when we press the trig button, okay, I'm doing it now, and I'm sorry, I'm just a little lazy about pulling the document camera out. Sorry, just don't feel like doing it. All right, so when you press the trig button, you should see a little thing that looks like 6. Okay, it's gonna look like that. So we're gonna have sine up here, and then the inverse of sine right here, and cosine right here, and tangent right here. Cosecant, secant, and cotangent, and then their inverses here. I really don't need to do all this. I don't know why I'm being so silly about it. Okay, so this is the button that I want to press. That is the inverse of tangent button. So when I press that, I'm going to highlight it with the mouse and press it. That is going to give me this. It's going to give me that on my calculator. And so I'm just going to have to populate this area right here. So the cursor should already be clicking in it, and all I got to do is type in it. So our first problem that we had was 15 minus 8i. So then this is going to be a negative 8 over 15. It's going to give us something really weird, but that's okay, right? So that's what I want. So that's what I'm going to type in here. So I'm going to say, I'm going to type in, I'm going to say negative 8 divided by 15, which should look like this. Maybe if I'm feeling, nope, feeling nice. Okay, actually, it should look more like this. I'm sorry, I just really don't feel like hooking up the document camera because it's so late. So it'll look like this, negative 8 slash 15. And that gives me negative 28.0725. Now, I'll tell you right now that our numbers that we're working with, they aren't going to give you something like that. It's going to give you 0, 30, 60, 45, or a negative version of those. Okay? When we're talking about theta, we've stuck to 0, 30, 45, and 60. Now, if it's negative, don't forget that if we're thinking of a circle, and this is the positive direction, and we get a negative, so we're going to go this way. So if I got, say, negative 60, remember what that is positively. If this right here is 60 degrees negative, then that means if I go around this way, it's 300 degrees positive. Okay? So you want to be careful of that. So anyway, I'm going to do the next one, which is, and this was number 3. We do not need to see that. So we're going to just do that for right now. Okay, so if I jump to the next one on our review, I've got Q, I believe it is. And Q says the square root of 11 minus I times the square root of 11. So what do? I push my trig button and then pick the inverse of tangent. So that's going to give me this on my calculator. And the cursor should be blinking in here. And after I do that, remember, just use your mouse and pick it. And so now I'm going to type the square root, which is control x squared, and that gives me the square root. And then I'm going to say 11. Now it says this is negative 11. So the negative needs to go on the outside. But honestly, it doesn't matter if you put the negative on top or on bottom. So I'm just going to put it on bottom. So I'm going to say, see, this is where it gets tricky. So I probably am going to have to get a document camera. The thing is, when I'm doing square roots and I want to do division by a square root, I need to have parentheses around the square root, a division sign, then parentheses again around well, I guess I could do it like that. Oh, no, let's do it. Let's do it like that. Square root of 11. So this is what I want to type. I want to have parentheses around my square root of 11. So I can put parentheses by just going to the parentheses, and there's a key on there. And if you put 1 in front, it'll put 1 in back automatically, and you can just keep moving. Okay, so that's divided by. So then when I divide, I'm going to get that little thingy thing there. And then I'm going to put another parenthesis and say negative, and then another parenthesis and say the square root of 11. And then all the parentheses should be closed, and I just press enter. And so if I do that, if I say the tangent is inverse of, big square roots around that. So if I said the square root of 11 divided by the negative square root of 11, that's the same as saying the inverse of tangent of negative 1. And that's going to be negative 45 degrees. So what does that mean? Negative 45 degrees means I take 360 and I subtract 45. It should be 315. So that's my argument for this one, for Q. My argument is going to be 315 degrees. This one was like negative 28 something. And so I would have had to do the same thing, but it's just, we're not going to work with 28. Trust me, it's going to be 0, 30, 60, 45, or the negative versions of it. Okay? You could have 120. What is it? 120, 135, 150, or 180. You could have 225, 240, was it 255? No, it's 180 plus 30 and then plus 15, and then I think it's 255, and then you get 270, and then you get 300. Let's see, 315 and 330 and then 360. Okay, each one of these is just an iteration of 30, 45, or 60. 120 is just a fancy way of saying, I believe it's 30, and then 135 is a fancy way of saying 45, and then 150 is a fancy way of saying 60. All it is just if I'm in the first quadrant, what you see is what you get: 30, 45, 60. But then when I'm in a second quadrant, I have to add 90 to all of my values. So 90 plus 30 is, guess what? 120. And then 90 plus 45 is, guess what? 135. And then 90 plus 60 is, guess what? 150. Right? And then when I go here, this is 180. So now I got 180 plus 30. Oops, I messed up my numbers. That was 210. So it's not 255. Come on, erase. You're making me look bad here. Yep, sorry, I'm old. I get old sometimes. So that's going to be 210. And then I've got 180 plus 45, that's 225. And then, so that's 225. And then I got 240. So 180 plus 60 is 240. And then here I got 270. And then here I got 270 plus 30, that's 300. And then 270 plus 45, that is 315. And then I've got 270 plus 60, that's 330. And that's 360, which is the same as 0. So see, it's just 30, 45, and 60 all over again. You're just adding these to it, okay? So you could get any one of those. We're not going to get anything weird like 28 point whatever. It's going to be one of these values, okay? So either you get 30, 45, 60, or you get something like, hey, I got a negative 60. So a negative 60 would be 300. Or I might get 120, and so on and so forth. I hope that wasn't too confusing. If it is, say something to me tomorrow. Okay. Convert a complex number from rectangular form to polar form. So this is number 4 in our review. So we want to take a complex number like 2 to the square root of, or 2 times the square root of 3 minus 2i. That is a plus bi. That is rectangular form. Yeah, rectangular form has an a and has a b. But see, polar form, which is r times cosine theta plus I sine of theta, it has two things. This is polar form, and polar form has r and r theta. So theta is the inverse of tangent of b over a, and then our r is just the square root of a squared plus b squared, or the modulus. That's the modulus. This is the argument. Okay, so I'm going to take those values and plug them in. So in this case, my a is 2 times the square root of 3, and my b is negative 2, right? Okay, so I'm going to plug those in. So I'm going to start with the argument this time. So for this problem, theta equals the inverse of tangent of negative 2 over 2 times the square root of 3, b over a. So if I look at that, that actually can be reduced to negative 1 over the square root of 3. And so either one of those will give me the same answer. So that is the inverse of tangent of negative 1 divided by the square root of 3. That is going to be negative 30. So what does that tell me? That tells me if I'm taking the inverse of tangent of 1 over the square root of 3, it's going to be 30. So because that's negative, it's going to be negative 30. So that's negative 30 degrees, or 330 degrees. So next I got to get the modulus. So the modulus is a squared plus b squared, which in this case is the square root of 2 times the square root of 3 squared plus negative 2 squared. Well, negative 2 squared is easy. It's 4. So I got 4 plus. Now, when I square the 2 times the square root of 3, I square both of those. So 2 squared is 4. The square root of 3 squared is just going to be 3. So I have 4 times 3. So that's going to be 12 plus 4. And remember, this is the square root of all that. That's going to be the square root of 16. Square root of 16 is 4. So now I have my r and I have my argument. So now I just plug and chug. So r times cosine theta plus I sine of theta is going to be 4 times cosine of 330 plus I sine of 330. That's my answer. If this isn't clear enough here, let's, whoop, shucks. Okay, it comes back now. I'm going to erase this so I can make it a little clearer. Okay, so that's sine of 330 degrees. And this over here was r equals square root of a squared plus b squared. So this is my answer for that. This is rectangular form. This is polar form. All right. I'm gonna go one more and then I'm gonna go check on the volleyball game. Okay, so number 5 says, it says divide a complex number. So in this case, the complex number we have is 3 minus 4i divided by 8 plus 15i. So when you divide, what you do is you multiply the top and the bottom, right? You multiply the top and the bottom by the conjugate of the denominator. So the conjugate of the denominator is going to be 8 minus 15i. So I'm going to multiply that top and bottom. So on the bottom, what ends up happening is that I get no more I, that the i's cancel each other out. So what that means is I'm gonna have 64. So 8, well, better yet, let's just write it out. I'm gonna have 8 squared plus 15 squared. See, that's is plus and minus, so it should be a minus, but that I times I is I squared, it's a -1, so that ends up giving me that. I'm going to have 8 squared plus 15 squared on the bottom. That's what multiplying something by its conjugate is going to do. Now this, I just got to do FOIL. 3 times 8 is 24. Then 3 times a -15i is -45i. Then I've got -4 times 8, that is a -32i. And then I've got -4i times a -15i. The negatives cancel each other off. 4 times 15 is 60. And then I've got I times I, so that's I squared. Now I got to simplify all this stuff. So simplifying the bottom is easy. Oh, sorry, got the hiccups. The simplifying the bottom is easy. That's just 64 plus 225. Now here, I've got two real numbers. No, I got a real number. I got the i's, and then I've got this number with the I squared. Remember, I squared is -1. So what's 60 times -1? It's -60. So I'm going to have 24 minus, now these two I can add. I've got a -45 and a -32. That's going to be -77i. And then here, that's going to be minus 60. So now I've got two real numbers. I can add those together and I get 289, right? No harm, no foul, right? And then here I've got 24 minus 60. That's going to be 36 negative. So negative 36 minus 77i. This is my answer. That's what happens when you divide two complex numbers. Okay, somebody's texting me that hasn't texted me in a long while. Okay, so that's number 5. What's number 6? Do I do number 6? Oh, yeah. Okay. Know the geometric effect of taking the conjugate of a complex number. So let's do that one, and then we'll call it. So if I have a complex number z, which is 8 minus 5i, the conjugate of z is 8 plus 5i, right? That's the conjugate. That's z. So what I want you to think about is when geographically, that's what we're talking about. Geographically. No, sorry, geometrically. Wow, not geographically. We're not talking about like locations. Metric. So geometrically, what's the geometric effect? Well, the geometric effect, we think about it in graphing. 8 negative 5i is what I'm looking at. So 8, 1, 2, 3, 4, 5, 6, 7, 8. Then negative 5i puts me down here. 1, 2, 3, 4, 5. That puts me right here. This is z, right? But then the conjugate of z is 1, 2, 3, 4, 5, 6, 7, 8 plus 5. So let me see. 1, 2, 3, 4, 5. So this is the conjugate. Wait a minute, something seems weird. What is going on here? Well, I'll make it easy for you. Geometrically, right? If I have something and its conjugate, right? They are going to be reflections of each other. That is the geometric effect. It's their reflections. If I give you something that's under here, so it's dealing with a negative from the start, the conjugate is going to be a positive. It's going to be reflections, not a ball across, sorry. Okay, across the x or real axis. So that's the left to right axis. So see how they're reflections, okay? So if you're given something like this, and I say I need to identify all of the pairs that are reflections of each other. So then if I had 1, 2, 3, 4, and 1, 2, and then 1, 2, these two points right here would be reflections of each other because they're both going to the same horizontal spot, but one is above the real axis and one is below, so they're reflections. So you want to look for points that have the same real coordinate, the same left to right coordinate, but one is above the real axis and one is below the real axis. Okay, so you'll be given a mixture of points, and we need to figure out which ones can be said to represent a real number and its conjugate. So we're just looking for reflections. Hope that makes sense to you. Now I got to stop this thing and I'm going to go check on the volleyball game.